It's 5 a.m. on a Monday, so time to do some math, obviously. Today we're going to be looking at extrema on an interval, and specifically the definition of extrema, and the definition of relative extrema, and how to find the extrema. So, if our function looks like this, it's defined on the interval 0, 4. It contains c. C is an x value that could be anything. Now, f of c, the y value that corresponds to that c, is the minimum of the function on the interval if the y value of that c is less than or equal to all the other y values for all the other x values in the interval. Basically what that means is this point right here is clearly the lowest y value. I will highlight it. That is clearly the lowest y value. So that is f of c if our c point is 0. Now, f of c is the maximum of f on the interval if f of c is greater than f of x for all x in the interval. So, very clearly, this is the highest point right here. So, if c equals 4, then f of c is the maximum of f. This brings us to the extreme value theorem. And the extreme value theorem says if f is continuous on a closed interval, then f has both a minimum and a maximum on the interval. So basically what it's saying is, doesn't matter what the function is, doesn't matter what the interval is, as long as it's continuous and it's closed, then the function has a minimum and a maximum. So let me draw another function on this interval up here. It is a parabola, but it's not symmetrical on the interval. So it's continuous. It's on a closed interval. It has a minimum and a maximum. And just looking at it, you can tell this is the maximum and this is the minimum. Okay, so sometimes the intervals are not closed, which means that we cannot determine the maximum and the minimum. So if this interval right here was closed, we would be able to determine that this point right here is the maximum and this point right here is the minimum. However, since this interval is now open for this situation, we're not sure exactly where this line ends. Say this is 4, it could be 3.9, 3.99, 3.999, just goes on forever. We can't determine it. We can still tell that this is the minimum because this side of the function does not continue on in this direction. If the interval was further this way, maybe it would, but as of now, this is still the absolute minimum. However, even if we can't find the absolute maximum and minimum, we can find relative maximum and minimum. So the definition of relative extrema: if there's an open interval containing c on which f of c is a maximum, then f of c is called a relative maximum of f. Or you can say that f has a relative maximum at c, f of c. And if there's an open interval containing c on which f of c is a minimum, then f of c is called a relative minimum of f. Or you could say that f has a relative minimum at c, f of c. So, this is our open interval, but say I want to find the relative maximum just in this area, because it looks like we have a peak in this area. So I can choose my own interval. I got this ruler. See if I can use it. There we go. Here, I'm going to make an interval right here. From just about 1/2 to just about 2. So let's say in this interval I want to find a relative maximum. Now it is clear that this point right here is higher than all the other points around it. So that is a relative maximum for that interval. Now, if I want to find a relative minimum, we already could, but in case the function didn't work out like that, let's find a relative minimum for this light blue interval that I'm drawing. So the interval is about 1 3/4 to 3 1/2, and it is clear that this is a relative minimum. Now go do some examples.